So we're going to measure the distance using EO and OF. So if EO is congruent to, or this distance here is congruent to OF, then we'll see that AB is congruent to CD. All right, and finally, let's take a look at our very last theorem. All right, so we have the diameter bisecting a chord theorem. So if a diameter is perpendicular to a chord, then it bisects the chord and the arc. So we have a diameter, and it's perpendicular to a chord, so I have to have some kind of degree measure. We have the chord and the arc, and then also importantly, because we have the diameter, that means we need a center. All right, so that means we're going to deal with the center. So let's go ahead and mark that. All right, and then let's mark our diameter here. Looks like that's a little bit inaccurate. Here, let's go here instead, or maybe here. All right, so we've got our diameter, and then we will have a chord, right? And we want to make sure that the chord and the diameter are at a right angle together. And so if this is true, then if we call this, let's name all these points. So we will write this as if ED is perpendicular to AC, then AB, well, it's going to bisect AC, right? So that means that AB will be congruent to BC because it's been bisected, so it's been cut perfectly in two. And we know something about the arcs. We know that the arc AD will be congruent to the arc DC. All right, so I know that's a lot of information to absorb right now. We have about 8 practice problems, and that's our assignment for today. And once you're done with those 8 practice problems, we'll go over them together and we'll glue them into our journals. So go ahead and pause the video here, and then we'll come back together, go over the answer to these problems, make sure that we have them all right. We'll put them in our journals, and then your final assignment for today will be to do your reflection. So once you are done with those 8 practice problems, go ahead and come back to this video and do your reflection. So your reflection here is going to be that in a circle, AB is a diameter and HG is a chord that intersects AB at some point x. Is it sometimes, always, or never true that HX is equal to GX? Explain. So just like we were doing earlier when we were trying to prove our theorems, draw a sketch first, right? You know your pieces of information that you have. You know your diameter. You need to make sure you have one of those. Then you have a chord, and you know that they intersect at some point. And what we're trying to find out is when is HG going to be congruent to, when is HX going to be congruent to GH? Thank you for your time. Have a wonderful day, and let me know if you have any questions. Goodbye.